In this video, we're going to explain how the node voltage technique works for analyzing circuits. So you start by taking a look at your circuit and you count however many nodes there are. Maybe 4 nodes, maybe 6 nodes, however many there are, you count them. You're going to pick any one of them to be a ground node, to be the ground for your circuit. Now, it does not actually matter if it is the real ground connected to earth ground or anything else here. All you're doing is you are choosing a reference point because all voltages are relative. So you're going to find the voltages relative to this node you chose ground. One little tip here, if you can choose a ground node that has multiple voltage sources attached to it, it will make your life easier, as we will see in some of the examples. Once you've chosen your ground node, every other node, you're going to create a variable for the voltage there. And again, that voltage is relative to the node you chose ground. We usually label these V1, V2, and so on. Then, for each node other than ground, you're going to use Kirchhoff's current law to write an equation for the sum of currents leaving equals 0. And we will use the version of Ohm's law that says the current leaving is equal to the voltage where you're at now minus the voltage where you're going to divided by R. After you've done this, there's one last step here, and that is that if you have any dependent sources, you look at what variables in your dependent source, and you define some way to relate that variable to your node voltage variables. That will give you extra equations here. Once you have all your equations set up, you use your linear algebra techniques to solve your system of equations, and you will have your answer. I give a little warning here, which we will see in an example or two, that if you happen to have a voltage source that is in between two nodes and neither one of them is ground, it's going to require a technique called a supernode that's going to make the problem a little bit more difficult. So just keep that in mind when we go to see those other examples. Now we're going to go ahead and solve this simple circuit here at the bottom using node voltage techniques. So as I said, starting up, we count the number of nodes. There's one node down here, there's 2 nodes right there, and there's the third node. So we have 3 nodes in this problem. We're going to pick one of them to be ground. Any of the 3 works. I'm going to choose the bottom to be ground. So then every other node, I will label them with variables. We'll call this V1 and this V2. Then for each one of those variable nodes, we go ahead and look at all the current that is leaving that node and use Kirchhoff's current law. So the current going down to the left, well really it's 1 amp going in, so current going out is -1. The current going down this 2 ohm resistor, well we're going to use Ohm's law. So we do the voltage change over the resistor, which is the voltage you're currently at minus the voltage you're going to, divided by R. And then lastly, we have our current going right, voltage we're currently at, minus voltage we're going to, over R equals 0. Then we're going to continue this, make an equation for our V2 node over here. Following the same process, voltage you're at minus voltage you're going to over R, that's the current going left out of here. Then the current going down the middle is going to be current voltage you're at minus voltage you're going to over R. And lastly, the current going out there is 4. We'll go ahead and clear out the denominators here. That's going to give me 3V1 plus 1V1 plus V1 minus V2 equals 6. And the bottom one we're going to go ahead and have to multiply by 42, it looks like. So that would be 7V2 minus 7V1 plus 6V2 is -168. So let's see here. I can go ahead and maybe multiply the top by 6 and add down. sorry, that's actually not going to quite work. One moment here. Maybe I'll just simplify this a little bit nicer before I decide what to do. So on top here I have 4v1 minus v2 is 6. On the bottom, negative 7v1 plus 13v2 is negative 168. So I guess I'll go ahead and multiply by 13 there. That gets me 52v1 minus 13v2, and 13 times 6 is 78. Add down here. 52 minus 71 is going to be 45v1, and negative 168 plus 78 is negative 90, so V1 is negative 2 volts. I can go ahead and plug it up in there to find out what V2 is. It would be negative 8 minus 6 is negative 14 volts. That gets me my voltage at the two nodes here, V1 and V2. And if I want to find the voltage across the resistors, I just do the voltage drops here. This one's V1 minus 0, so it's going to be a negative 2 volts. This one's V1 minus V2 here. That would be 12 volts. And then this one's V2 minus 0, which is negative 14 volts. And I've gone ahead and found the voltage across each resistor.